There is a place in the sky that should not exist. You cannot see it, not with your eyes, not on the clearest night from the darkest field you could ever find. It sits in a quiet, unremarkable patch of the northern sky in the constellation of the hunting dogs. And to look at it, you would need a telescope and patience and a very particular question in mind. But it is there. It has been there for longer than the Earth. It has been there for longer than the sun. And right now, as you breathe, something from it is arriving. Light. Old light. Light that left its source more than 10 billion years ago, when the universe was still a child, when there was no Earth, no ocean, not a single atom in your body arranged into anything you would recognize. That light has been crossing the dark ever since, and tonight, a thin sliver of it is landing on mirrors on mountaintops all over this planet. And a fraction of those mirrors belong to the most powerful telescope humanity has ever built. The object is called TON 618, and it is the largest black hole we have ever confirmed. We will get to the numbers. We will get to how big largest really means, because the honest answer is almost impossible to hold in your head. But the number is not the frightening part. The frightening part is quieter, and it took the James Webb Space Telescope to make it clear. Because for decades, TON 618 was treated as a freak. A single, impossible monster. Too big, too old, too early. An exception we could file away and mostly ignore. And then Webb turned its eye on the early universe, on the first few 100 million years after the Big Bang, and it began finding the impossible again, and again, and again. TON 618 was never the exception. It was the first warning. This is the story of what it is, how it broke our rules, and why the deeper we look, the worse the problem gets. Before we go any further, we need to clear something up, because the picture most people carry around in their heads is wrong. A black hole is not a cosmic vacuum cleaner. It does not roam through space, reaching out across the dark to drag in anything that drifts too close. That is not what it does. If you replaced our sun right now with a black hole of exactly the same mass, the Earth would not be pulled anywhere. Our orbit would not change. The planets would keep turning in their lanes, exactly as they do tonight. We would freeze in the dark, yes, because the warmth would be gone. But gravitationally, nothing would move. Nothing would fall. A black hole is simply a place where an enormous amount of mass has been packed into an extraordinarily small space. That is all. Stand far away from it, and its gravity behaves like any other objects. It is only when you get close, truly close, that the strangeness begins. Because as you approach the center, the pull grows and grows until you reach a point where it becomes so strong that even light cannot climb back out. Light, the fastest thing there is, tries to leave and fails. The edge where light loses that fight has a name. We call it the event horizon. It helps to think of the event horizon not as a wall, but as a door that only opens one way. Cross it, and the universe behind you simply stops being a place you can ever return to. Not because something is holding you back, but because there is no longer a path that leads out. Every direction you could possibly travel now leads further in. And that door, around most black holes, is small. Around TON 618, it is anything but. Most of the black holes we know of fall into two groups. The first are the small ones, though small is doing a great deal of work in that sentence. They form when a massive star reaches the end of its life and collapses under its own weight, and they end up weighing somewhere between a few and a few dozen times the mass of our Sun. There are likely hundreds of millions of them scattered through our galaxy alone, drifting, dark and silent. The second group is far stranger. These are the supermassive black holes, and they sit at the centers of galaxies, including ours. The Milky Way has one. It is called Sagittarius A star, and it weighs about 4 million times the mass of the Sun. A few of these giants we have even managed to photograph. The black hole at the heart of the galaxy M87, 55 million light-years away, was the first ever captured directly. A dark circle ringed in fire, an image that took a network of telescopes spanning the whole planet to produce. Here is something worth holding on to. Nearly every large galaxy we have ever examined has one of these supermassive black holes at its center. Ours does. Andromeda does. The pattern is so consistent that astronomers have come to suspect the black hole and the galaxy around it grow up together, somehow shaping one another across billions of years. How a thing the size of a single point comes to be bound so tightly to a structure 100,000 light-years wide, we still do not fully understand. But the link is there in the data, galaxy after galaxy. The monsters are not intruders. They appear to be part of how galaxies are built. That was the scale we had grown used to. Millions of suns, a few billion at the very most. Big, but explainable. A number that, however vast, at least sat still. And then came TON 618. It was first noticed in 1957, though no one knew what they were looking at. During a survey at the Tonantzintla Observatory in Mexico, astronomers catalogued thousands of faint blue points of light. One of them was the 618th entry on their list. That is where the strange name comes from. TON for Tonantzintla, 618 for its place in a catalogue. Nobody thought much of it. It looked like a dim blue star, one of thousands, unremarkable in every way. It took another 15 years to realize the object had been misidentified completely. By the early 1970s, better instruments revealed that this faint blue star was not a star at all. It was a quasar, the blazing core of a distant galaxy, a place where a central black hole is actively feeding, surrounded by a disk of doomed matter so hot and so bright that it outshines every star in the galaxy around it. The light we had filed away as a dim little star had, in fact, crossed most of the observable universe to reach us. And when astronomers measured exactly how far, the answer reframed everything. The light had been stretched by the expansion of the universe so dramatically that they could calculate its journey. It had been travelling for more than 10 billion years, which meant the light reaching us had left its source when the universe itself was less than 4 billion years old. An infant cosmos. A time before the Earth, before the Sun, before our own galaxy had finished taking shape. And the object that produced it was, by every measurement we could make, utterly unreasonable. Here are the numbers, because this is where TON 618 stops being merely interesting and starts being frightening. Our Sun, by any human standard, is enormous. You could fit roughly 1.33 million Earths inside it. And yet, set against the largest stars in our galaxy, the Sun is unremarkable, even a little small. Scale out here is relative. So hold the Sun in your mind, and then try to do something almost impossible. Try to imagine tens of billions of them. The mass of TON 618 is staggering, and it comes with honest uncertainty. The most widely quoted estimate from an analysis in 2004 puts it at around 66 billion times the mass of the Sun. A more recent study in 2019, using improved methods, revised that figure downward to around 40 billion. Astronomers still debate which is closer to the truth, because measuring the mass of something 10 billion light-years away from the width of a single line in its spectrum is genuinely difficult. But here is the thing. It does not matter which number is right, 40 billion or 66 billion. Either one places TON 618 in a category of its own. There was no ordinary word for a black hole this heavy. Astronomers had to invent one. They call it ultramassive. At the upper end of that estimate, this single object would outweigh every star in the Milky Way combined. Not the galaxy, the stars inside it. All several hundred billion of them poured into one point and still falling short. Its event horizon, that one-way door, has a radius of roughly 1,300 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. Pluto, at the far edge of our solar system, orbits at about 40, which means the event horizon of TON 618 reaches more than 30 times past Pluto in every direction. From edge to edge, it spans thousands of times the distance from here to the Sun. You could line up dozens of complete solar systems across that gap and still have room to spare. Light itself, the fastest thing in the universe, would take about 2 weeks to cross from one side of it to the other. 2 weeks for a beam of light to traverse a single hole in space. Imagine for a moment that you could hover near the edge of it, which you could not because you would have died long before you arrived. But imagine it anyway. What would you see? You would see the universe bent into a single point. Space itself would be warped so severely that the stars behind you would appear in front of you, smeared into thin rings of light. Every galaxy you could see would be lifted and curved into a bright halo arching above your head. Your watch would tick slower than a watch on Earth and drift a little closer, and a single minute of your time would stretch into a century for everyone you left behind. And below you, where the black hole waits, there would be nothing. No light, no texture, no surface your eyes could fix on. Just a perfect circle of absence, so complete that your mind would refuse to read it as an object at all. Not a shape, not a thing, just the bottom of everything. And there is something stranger still about a black hole this large, something that runs against every instinct. With a small black hole, the danger is the falling itself. The pull on your feet would be so much stronger than the pull on your head that you would be stretched into a thin stream of matter long before you ever reach the center. Astronomers have an almost gentle word for it: spaghettification. But TON 618 is so vast that its horizon is smooth and shallow by comparison. You could cross it without feeling a thing. No wall, no violence, no sensation at all. One moment, the universe behind you is still a place you could return to. The next, in silence, it is not. You would never know the instant you pass the point of no return. And that is only its geometry. We have not yet talked about what it is doing. Because TON 618 is not a quiet black hole sitting still in the dark. It is a quasar. It is feeding. A constant river of gas and dust and whole stars is spiraling inward, torn apart and heated by friction to millions of degrees before it crosses the horizon and vanishes. That superheated disk is what shines. At the scale of TON 618, entire star clusters could be devoured over the course of a single human lifetime, and the quasar would barely register the meal. And we have watched a gentler version of this happen. Around smaller black holes, nearer to home, astronomers have caught the moment a star wanders too close and is torn apart. A sudden flare of light, brightening over weeks as the shredded remains of a sun spiral inward and burn. They call these events tidal disruptions. At the scale of TON 618, an entire star pulled to pieces would be little more than a flicker, a single mouthful in a feast that has already lasted billions of years. Its brightness is estimated at around 140 trillion times that of our Sun. If you set the entire Milky Way beside it, every one of its hundreds of billions of stars, TON 618 would outshine the whole galaxy by a factor of thousands. One object brighter than thousands of galaxies put together. That blaze is how we found it. And the quasar does not burn alone. Wrapped around TON 618 is a vast cloud of glowing gas, a structure astronomers mapped using radio telescopes in the high desert of Chile. It stretches more than 300,000 light-years across, more than twice the width of the entire Milky Way, one of the largest single objects of its kind ever found, lit from within by the monster at its core. The light is only the symptom. What lies underneath is the thing that should frighten you. Because once you do the arithmetic on what lies underneath, the numbers turn from frightening to impossible. A black hole of 66 billion solar masses should not exist only 4 billion years after the Big Bang. Black holes grow in two ways. They swallow matter, and they merge with other black holes. Both take time. Even a black hole feeding as fast as the laws of physics allow, a rate called the Eddington limit, where the light pouring off the infalling matter pushes back hard enough to choke the flow. Even feeding flat out, it only doubles its mass every few tens of millions of years. Run that mass forward, and you simply cannot grow a 66 billion solar mass black hole, starting from a single collapsed star, in the few billion years available. There is not enough time in the young universe to build something that size by the ordinary route. And yet there it is. The light is real. The mass is real. The clock is real. They do not fit together. So astronomers have three ideas for how it happened, and none of them is comfortable. The first is called direct collapse. In the early universe, before stars had cluttered everything with heavier elements, vast clouds of pristine gas may have skipped the whole business of forming stars and collapsed straight into black holes. Not small ones, but seeds already 100,000 times the mass of the Sun. Start that big, and you have a head start enormous enough to reach billions of solar masses in the time we have. The second is runaway mergers. In the dense, crowded hearts of the very first galaxies, stars collided and collapsed and formed black holes, and those black holes found one another and merged again and again, each collision kicking the growing monster up into a heavier weight class. Repeat that fast enough, and you arrive at something like TON 618. And the third idea is the one that has quietly been gaining ground: that some black holes were not built at all, that they formed in the first fractions of a second after the Big Bang, born directly out of the chaos of the newborn universe, before the first star had ever lit. Primordial black holes. In that version of the story, TON 618 was never a thing that became a black hole. It was born one in the opening moment of everything, and it has been feeding ever since. We do not know which answer is right. We may never know. But every model on the table forces us to admit the same uncomfortable thing. The early universe was building giants far faster than our rules say it ever should have been able to. And for a long time, we could almost live with that, because TON 618 was one object, a single outlier, far away and long ago, one freak result you could quietly set to the side. And then, the James Webb Space Telescope opened its eye on the early universe, and the outlier stopped being alone. Webb was built, in part, to look further back in time than anything before it, into the first few 100 million years after the Big Bang. And almost at once, it began finding things it was not supposed to find. Tiny, intensely red points of light, scattered across the young cosmos in far greater numbers than anyone had predicted. Astronomers have taken to calling them little red dots. And as the data has come in, through last year and into this one, the most likely explanation has only grown stranger. Many of them appear to be black holes, supermassive black holes, already grown to millions or billions of times the mass of the Sun, sitting in galaxies so young they had barely begun to assemble. Some researchers now describe them as something close to black hole stars, objects feeding so ferociously in such violent bursts that they blaze past every limit we thought applied. And the theories being argued over to explain them are the very same three we just met: direct collapse, runaway growth, seeds left over from the dawn of time. Webb did not solve the mystery of TON 618. It did something worse. It revealed that TON 618 was never strange at all. The early universe is full of them. The deeper we look, the more monsters turn up, and the more certain it becomes that this record, the largest we have ever confirmed, will not hold for long. And in truth, the crown is already contested. There are other giants out at these distances, with names that read like catalogue numbers, and a few of them may be heavier still. The measurements come with enormous uncertainty, error bars wide enough to reshuffle the ranking entirely, which is part of the unease. We cannot even say for certain which monster is the largest. We only know that the list is far longer than we ever expected, and that it is still growing. Which brings us, finally, back to the question we started with. The one that has probably been sitting in the back of your mind this whole time. Is TON 618 coming toward us? The answer has two halves. The
first is no. The object itself is not approaching. The opposite is true. The expansion of the universe is carrying TON 618 away from us, faster every year. As you watch this, the distance between the Earth and that black hole is growing. In the most literal, measurable sense, it is retreating into the dark, and we will never grow any closer to it. Even light, moving at full speed, would take more than 10 billion years to make the trip. We can never visit it. We can never send anything to it. We will never see it as it is now, only as it was, when its light first began the journey. And that is the second half. Because something from TON 618 is arriving. It's light. The photons reaching the telescopes tonight left when the universe was less than 4 billion years old, and they have been crossing expanding space ever since, aimed at a patch of emptiness where, one day, a planet full of curious creatures would point a mirror back. Most of that light was lost along the way. A tiny fraction survived. It is landing now. And it will keep landing for as long as anyone on Earth keeps looking up. We are not in danger from TON 618. The maths on that is clean. It is far too distant to touch us, and the expanding universe guarantees it always will be. But danger is not the only way a thing can frighten you. TON 618 is frightening because it reminds us that we do not live in a universe we fully understand. The rules we wrote down about mass and gravity and time hold up beautifully in the quiet neighborhood around our sun. Out at the edges of what we can see, they begin to look more like rough drafts. And even this will not last forever. Given enough time, longer than the universe has yet existed, longer than the mind can truly hold, even a black hole slowly leaks itself away, evaporating into the dark until nothing is left. For TON 618, that ending lies almost unimaginably far in the future. But it is coming. The largest monster we have ever found is, in the deepest sense, temporary. It is simply outliving everything else by an amount of time the universe has not yet had. If you could stand outside our galaxy and look back toward home, the Milky Way would fill your sky. Hundreds of billions of stars, every war and every love story and every name ever spoken, all of it gathered into one faint spiral of light. And TON 618, alone at the heart of its distant galaxy, outweighs that entire spiral by itself. The light from that single point is what lands in our telescopes tonight. And the message it carries is short. It says, "You do not know how big things can get. You do not know how fast they can grow. You do not know how much of the universe is still hidden from you." And somewhere out there, in a present we will never witness, the sender is still there, still feeding, still growing, and every night, a little more of its ancient light completes its 10 billion year journey, slips quietly into a mirror on some lonely mountaintop, and reminds us how small our map of the universe still is. Webb is still looking, and the dark, it turns out, is far from finished with us.